Alright, so today we'll be doing search a 2D matrix, another fun problem. Let's check it out. In this particular problem, we want to search for a number. If it's in our array or not, we don't have to return the row or column, but we just have to return whether it's in here or not. So the fastest way is to do a binary search for the item in the row. So to find the correct row, and also find the correct if the item is in that row using binary search. So this is O of log n times O of log m, number of rows and number of columns. So if you've seen the binary search problem, this would be very similar. And what we're gonna do is to make sure the largest value, the target, if it's greater than the largest value, then, well, it has to be greater. If it's smaller than the smallest value, then it has to be smaller. And that means we can move, if we have a top pointer and a bottom pointer, we can move the top pointer down if the item is bigger, and we can move the bottom pointer up if the item is smaller, target is smaller. All right, let's just check it out. Let's see how it's done. All right, so let's do a top and bottom pointer equals 0, and the rows, which is length matrix, minus 1. All right, so while top is less than or equal to bottom, what we're going to do now is find the mid, which is equal to top plus bottom divided by 2. So let's see, largest, smallest value, row value, and largest row value is equal to, well, the matrix of the mid of 0 is the smallest value, and matrix of mid and -1 is the largest value of the particular row. So if our smallest value is less than the target, well, greater than the target, less than the target, greater than the target. So if our smallest item is greater than our target, it must mean that our target is in the bottom half of this item. I mean the top half of this item. So that means we need to move our bottom, our bottom is now equal to mid minus 1. Else if the largest row value is less than the target, that means it's in the bottom half of the items. So that means top equals mid plus 1. Otherwise, we have found it, and so we should break. Now, let's select the row, which is equal to matrix of mid. With that found, oh, right, one more thing. So if the top is greater than the bottom, that means they have gone past each other. We need to return false out of this. Okay, well, that's that, and let's do left and right. I think this is overkill, but let's just do it anyways. By overkill, I mean the variables left and right. Usually L means left and R means right. Because of how many times we have used it, usually we can do it as shorthand because it's so obvious based on the context that we've had, that what it means. So I mean that's what I mean by overkill. But maybe this is not overkill. Maybe it is. I don't know. We'll see. It does take a little bit more typing because of the length of the word. So basically this is the regular, binary search. So if the item is greater than the target, then we need to find a small target. So right equals mid minus 1. Else if selected row of mid is less than the target, that means we need to find a bigger item. Else, we can return true. Otherwise, we'll return false because we didn't find anything. And let's run the code. Submit. Okay, very good. I think that went pretty well. We can use bisect that we learned the last time. The timing is very funky because, I mean, it's the same function, but we get different results every single time, it seems. So, right. When we use, well, if we use bisect, let's try that and give it a shot. See what happens. So, index is equal to, let's say, bisect right. Oh, bisect means just bisect right. And so what we're going to bisect is our selected row, and we're going to look for our target. So if the index is greater than 0, then index minus equals 1. With that, we can return true, return index is equal, selected row of index is equal to target. If it's not equal to target, then return false. I mean, of course, then, looks like there's no bisect here, so let's just use bisect right because this is not built in. Bisect is not built in. And there we go. Pretty cool, right? That's something we just learned recently. And let's do bisect left, just for funs. So what happens when you do bisect left? If bisect left, if index is equal to the length of selected row, return false, or selected row of index does not equal to the target, return false. Otherwise, we can return true. Or we can return equals to target. I think that's the easier one. I think we can do even better than that. We can do let's return it first. I'm thinking of a way to combine these two together to make this a little bit more close. I'm not sure actually how to do it right now. Maybe this works. I'm not sure. We can try that. It might not work. It might blow up in their face. But, I mean, why not try, right? Run the code. So let's submit. Wow, it worked. Hey, that's pretty cool. And so that's how we use bisect left and bisect right to, simplify our code a little bit. But in the end of the day, I mean, it's nice to have this access to no binary search so that we can know exactly what we're eliminating from the left and right side, or top and the bottom side, whatever we don't need. Because I don't see how we can, we can like manipulate this this matrix, but then it's just, well, it's not the same. Okay, if you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much, and I will see you in the next one.